Hello and welcome in this video, and the topic of today's video is trigonometry. So, we will discuss some basic ideas, or we can say the formulas related to the trigonometry. We also discuss about the problems related to the trigonometry. So, first of all, what do we mean by trigonometry? So, trigonometry is basically a branch which deals with sides and angles of a triangle. Okay. So, this is the main task which trigonometry help us to do. Now, in general, if we have a right angle triangle, let us say this is our right angle triangle, let us call it as A, B, C. So, this is a right angle triangle. So, angle B is 90 degree. So, it is very clear that angle A and angle C are acute angles. So, we will discuss about the trigonometrical ratios of acute angles. Okay. So, trigonometric ratios of acute angles. So, we generally establishes certain relationship between the angles of a triangle and in terms of the ratio of the sides. So, in general we have 6 trigonometrical ratios. So, we are having 6 trigonometrical ratios. So, we have 6 trigonometrical ratios, and these ratios are sine, we have cos, tan, cot and sec, and we have cosec. So, we have these 6 trigonometrical ratios. So, before we begin with the problems related to these ratios and some trigonometrical identities, first of all we should have a very clear understanding about how do we obtain these ratios, and means how we can express these trigonometrical ratios in terms of the sides. So, before that, let us discuss these angles first. So, if you consider the angle A, so if you consider this angle A, so in this right angle triangle we are very much clear about that this triangle has AC as hypotenuse. Okay, so AC is our hypotenuse, and so when you talk about the angle A, so the side AB for angle A, so AB is the adjacent side. Okay. So, this is adjacent side, means this side is adjacent to angle A, because you can say that this angle A is lying between the hypotenuse and the side AB, and for this angle BC is the opposite side. Okay. So, this is our opposite side. So, if you look at this, so angle A, and you can see that this BC is the opposite side to angle A. Similarly, when you talk about angle B, not angle B, because we are discussing the acute angle. So, this angle C, so for this angle C we have BC. For this angle C, now BC is the adjacent side. Okay. So, as you can see that angle C is adjacent to side BC, and AB is the opposite side. Okay. So, as you can see that for angle A, AB is the adjacent, but for angle C, AB is the opposite. So, this is a change, means sides will be reversed. Here AB is adjacent to A, but and BC is opposite side to angle A, but here you can see that BC is adjacent side to angle C and AB is opposite side to angle C. So, now if we have to find the sine of angle A, means sine of angle A. So, for sine we always use the opposite side to the particular angle. So, here we will consider opposite side to angle A divided by the hypotenuse. Okay. So, this will give you as you can see that here for angle A, the opposite sine is BC and the hypotenuse is AC. Now, if you are finding sine of angle C, so again the formula is same, but only changes now we are considering angle C in place of angle A. So, we should consider opposite side to angle C divided by the hypotenuse. So, as you can see that for angle C, the opposite side is AB and the hypotenuse is same, so which is AC. Now, when we talk about the cos of any angle, so first of all cos of angle A, because we are considering only the acute angle. So, here because the angle B is 90 degree, so it is very much clear that angle A and angle C both are acute angles triangle. So, here if you are finding cos of angle A, so the formula for cos of any angle is we should consider the adjacent side. Okay, so adjacent side to angle A and this should be divided by the hypotenuse. So, adjacent side to angle A is AB and hypotenuse is AC. So, from as you can see here that if you are considering the angle A, so the side AB is the adjacent side to angle A. Now, similarly, the cos of the second acute angle, means cos of angle C, is again here we are using the same formula. So, adjacent side to angle C divided by the hypotenuse. So, if you are looking at this, so for the angle C, the adjacent side is BC. So, this will be BC over AC. So, from here you can clearly see that sine of angle A will be same as cos of angle C and the sine of angle C is same as cos of angle A, because when you consider the angle A and angle C, so here you can see that. So, here you can see that the adjacent and opposite sides are reversed. So, that is why sine of angle A will be same as cos of angle C and sine of angle C will be same as cos of angle A. Now, the next trigonometrical ratio is tan. So, if you are finding the tan of angle A, so tan of any angle is obtained by considering the side opposite to that particular angle. So, here this angle opposite side to angle A and divided by the adjacent side. Okay, so adjacent to angle A. So opposite side to angle A is BC, and adjacent side to angle A is AB. So this is how we can obtain our tan of angle A. Now similarly, if you want to obtain tan of angle C, so this will be side opposite to angle C divided by adjacent to angle C. So side opposite to angle C is BC, and adjacent to angle C is as we can see here that adjacent side to angle C is BC. So this will be okay. So let's once again check this. So here you can see that angle C. So we are finding tan of angle C. So BC is adjacent and AB is opposite. So this will be AB over BC. Okay, so this will be AB over BC. Now when you consider the next trigonometrical ratio, so that is cot, and cot of angle A is just obtained by taking the ratio of the adjacent side to angle A divided by the opposite side to angle A. So this will be AB over BC. Similarly, if you want to obtain the cot of angle C, so that will be again here we are using the same approach, that adjacent side to angle C divided by opposite side to angle C. So that will be BC over AB. So this is how we can obtain the cot. Now if we continue, so our next trigonometrical ratio is sec. So sec of angle A is, here we should consider the hypotenuse in the numerator, and in the denominator we have to consider the adjacent side to angle A. So our hypotenuse, if you look at this diagram, so in this diagram hypotenuse is AC. So this is AC and adjacent side to angle A is AB. So this is how we can obtain our sec A. Now if you obtain the sec of angle C, so that will be again hypotenuse divided by the adjacent side to angle C. So this will be AC over if you look at the adjacent side to angle C, so this is BC. And lastly, our sixth or last trigonometrical ratio is cosec. So cosec of angle A is hypotenuse, and we have to consider the opposite side to that particular angle. So that will be hypotenuse is AC and opposite side to angle A is BC. And if you consider the cosec of angle C, so that will be hypotenuse divided by the opposite side to angle C. So that will be AC, and opposite side to angle C is AB. So this is how we can obtain the different trigonometrical ratios, and it is very important to consider the right consider the sides in the right manner, because if you are finding the trigonometrical ratio for the angle A, so the AB is the adjacent side, BC is the opposite side, and AC is fixed. So, AC is hypotenuse in every case, but yes, the role of AB and BC will get changed once you are considering angle A and angle C. For angle A, AB is the adjacent side and BC is the opposite side, but for angle C, BC is the adjacent side and angle AB is the opposite side. Now, the impact of this is if you are finding the sine of angle A, so that will be a BC over AC, as you can see. So, sine of angle A is BC over AC, while the sine of angle C is AB over AC. So, it is not generally students learn that sine is perpendicular upon hypotenuse. So, that is true, but if you are considering sine of angle A, so if you are considering AB as the perpendicular for this triangle and BC as base and AC as hypotenuse, so you will consider sine A as AB over AC, so that will be wrong. Okay. We cannot consider this sine of angle A as AB over BC, because for sine we have to consider the opposite side. So, sine of angle A is BC over AC. So, now based on the above discussion, we can establish a relationship. Okay. So, we can establish a relationship among different trigonometrical ratios. Okay. So, we can establish relationship. Okay. So, the relationship is, if you are considering a general, let us consider theta as a general acute angle. Okay. So, acute angle of a right angle triangle, So, you have sin theta as sin theta and cos theta as cos theta, but when you talk about the tan theta, so tan theta you can write as sin theta over cos theta, and similarly when you talk about the cot theta, so cot theta is cos theta over sin theta, and sec theta is 1 over cos theta, and similarly cosec theta is 1 over sin theta. Okay. So, these are the relationship among the different trigonometrical ratios, and these ratios you can easily obtain from here. So, if you suppose you are fixing a particular angle, means suppose if you are fixing, let us say you are fixing the angle A. Okay. So, let us consider angle A. So, if you look at for angle A, if you look at this sine of angle A, so sine of angle A is BC over AC. Okay. So, you can write this sine of angle A as BC over AC. Now, similarly cos of angle A as AB over AC. So, this is given here. So, cos of angle A is AB over AC. Now, you can easily obtain this relation if you look at the tan of angle A. So, tan of angle A is BC over AB, and if you divide sine of angle A by cos of angle A, so that will be BC over AC divided by AB over AC. So, you will easily obtain this as BC over AB. Okay. So, similarly you can obtain the other relation also, means if you look at this sec of angle A. So, sec of angle A is given here. So, this is AC over AB, while cos of angle A is AB over AC. So, from here and here you can easily obtain that sec of angle A is same as 1 upon cos of angle A. Okay. So, this is how we can obtain the different trigonometrical ratios, and again I would like to mention that it is very important to consider the adjacent sides, opposite sides and hypotenuse. Hypotenuse is fixed, but you have to be very careful when you are selecting the adjacent and opposite sides, because once you are dealing with the different trigonometrical ratios, so it is very important to select the sides in the correct manner. Okay. So, that is all in this video, and in the next video we will come with some more concepts related to the trigonometrical ratios and in particular trigonometry. Okay. So, that is all.